Welcome back to chemistry. Okay, we are still talking about mole conversions. But before we get started on the new stuff, let me do a quick recap of what you were doing last time. Last time you learned that 1 mole is equal to the GFM, the gram formula mass of any compound. Remember, you break apart the compound, you pull out all the players and how many you have, you look up the weights on the periodic table, then you add them all up, the GFM. We also learned that 1 mole is also equal to 6.02 times 10 to the 23rd atoms, molecules, or particles. Remember, this is a how many number. So if I say 1 mole, it's always going to equal 6.02, just like 1 dozen is always equal to 12. So this is a how many number. And in the case of chemistry, we're talking about atoms, molecules, and particles instead of eggs. We also learned that 1 mole is equal to 22.4 liters if you're at STP. STP stands for standard temperature and standard pressure. Standard temperature is 0 degrees Celsius and standard pressure is 1 atmosphere. But y'all don't have to worry about that because all of our calculations this year is going to be at STP. So all we have to worry about is this 1 mole equals 22.4 liters. Then I gave you this mole diagram, which we're going to be using today. It's our map to convert. If you want to convert between mass and moles, you got to use the GFM. If you want to convert between volume and moles, you got to use 22.4. And if you want to convert between moles, atoms, molecules, or particles, you got to use 6.02 times 10 to the 23rd. Remember, we're using dimensional analysis to do all of our conversions. They're going to give us some number. Remember, we only care about 2 places when we're doing these problems, the starting point and the ending point. Everything else in the middle is just extra information, okay? So we only care about the starting point and the ending point. Once you know the starting point and ending point, you can map out on the Y diagram what you're doing and how many moves it takes, and then this doesn't change. You got your given unit. Whatever's up here goes down there, only the unit, not the number. Whatever's up here goes down there. So if I have liters up here, you're going to put liters down here. If you have moles up here, you're going to put moles down here. And where you want to go goes up top. Okay? Remember, if you're not in moles, you're going to convert to moles first, right? You always go to moles first. But if you're already in moles, then you can go anywhere. Okay? If you're already in moles, you can go anywhere. So this brings me to today's stuff. Today, we're still doing mole conversions, but now we're doing 2-step mole conversions, okay? Very important, 2-step mole conversions. We're getting closer and closer to stoichiometry. You'll know what that is later, but I'm giving this to you little steps at a time so you can get it. So let's look at our problem here. They gave us 59.5 grams of NH3 and they want us to go to liters of NH3. Okay, so I'm going to write that down. We're going from grams to liters because all I care about is my starting point and ending point. Okay, now I got to figure out how many moves it's going to take me to get from grams to liters. So I'm going to pull out my Y diagram again. Okay, here's my Y diagram. Here's grams and here's liters. How am I going to get from here to here? Well, I got to follow this roadmap here. First, I got to go from grams to what? To moles. And then I got to go from moles to volume. So if you go from grams to moles and then moles to volume, that's 1 step, 2 steps. This is a 2-step problem, okay? So I'm going to set this up as a 2-step problem. If I have 59.5 grams, I always write down what they gave me, right? And I know this is 2 steps, so this is going to be 2 sets of these boxes, okay? 2 sets of boxes here because it's a 2-step problem. Now, our first step is to go from grams to moles. So let's do that first, okay? Remember, whatever unit is up here, we're going to put down here. We don't care about numbers yet. We're going to fill this up with units first and then put in numbers. So let's do that. Whatever is up here goes down there. So I'm going to put grams. And if you look at the Y diagram, from grams you go where first? to moles. So I'm going to put moles up here. Whatever's up here goes down there. So I'm going to put moles down here, right? And where did we want to go to? Well, now that we're in moles, we can go to volume like we wanted. That's why I said if you're not in moles, you go to moles first, and once you're in moles, you can go anywhere. So now I can go to my liters. Now it's time to plug in numbers, okay? Let's do the easy ones first. Here's our conversion factors right here. What does mole always get? Moles always get 1. So everywhere you see a mole, you're going to plug in 1. Now look for liters, the L. What does L get? L always gets 22.4. And what does grams get? I have to calculate the molar mass. So what do I got to calculate the molar mass of? Well, you got to do it of NH3. So I got to do that first. This is the hardest part about dimensional analysis, is calculating molar masses. So if I look, I got 1 nitrogen and 3 hydrogens. Okay, I broke it apart. If I look it up on the periodic table, nitrogen weighs 14.007. I only have 1 of them, so that equals 14.007. Hydrogen on the periodic table weighs 1.008. I have 3 of those guys, so that's going to give me 3.024. My last step is to add these guys up. So 7, 8, 9, 10, 11, 3 zeros. So that gives me 17.031 grams per mole. Okay, so I just calculated my molar mass. Now I can plug it into here. 17.031. Okay, so guys, now my chart's completely filled out. Remember, we only got to calculate the molar mass, the GFM, if we're going from grams to moles or moles to grams. We only do that with the gram boxes. So now our last step, you're going to multiply the top together, you're going to multiply the bottom together, and you're going to save dividing for last. Okay? So if I pull out my calculator and I go 59.5 times 1 times 22.4, that's going to give me 1332.8. And if I go 17.031 times 1, that's 17.031. So now if I divide last, this divided by that, that's going to give me 78.3 liters of NH3. Okay? And that's our answer. So if I have 59.5 grams of NH3, that is equal to 78.3 liters of NH3. So we just converted from grams to liters. So let's now do another example, okay? This time we're going to reverse the process. We're starting off in liters, and we're going to go to grams. Before, we started off in grams, and we went to liters, from grams to liters. But now we're going to go from liters to grams. So I got to figure out how many moves this is going to be. So I'm going to look right here in my Y diagram. I'm starting off right here in liters, and I have to get to grams. Well, let's look. If I'm in liters, I got to go to moles first. That's 1 step. And then once I'm in moles, I got to go to grams. So that's 2 steps. So I go to moles first, and then once I'm in moles, I can go anywhere, but I want to go to grams. So this is a 2-step problem. So I'm going to start off with what they gave me. 5 liters of O2. 1 step, 2 steps, okay? So whatever's up here goes down there, so I'll have liters, so I'm going to put liters. And then we always go to moles first, right? So I'm going to go to moles. Whatever's up here goes down there, moles. Once I'm in moles, I can go anywhere, but where do I want to go to? I want to go to grams. So our starting point and ending point is all we care about, liters to grams. So I got to go from liters to grams. Whatever's up here goes down there. You always go to moles first, unless you're in moles, and then from moles to grams. Whatever's up here goes down there. So this chart fills itself out. If you know the beginning guy and where you want to go to, this chart will always fill itself out. So now let's plug in numbers. Let's look at our conversions. What do moles always get? Moles always get 1, so I'm going to plug in these 1s. What does liters always get? Liters always get 22.4, so I'm going to plug in my 22.4. Okay? And what does grams get? Well, if you see a grams box, we got to calculate the molar mass of the compound. Okay? In this case, it's O2. So if I have to calculate the molar mass of O2, that's 2 oxygens. So 1 oxygen weighs 15.999. So I'm going to say times 2. That's going to give me 31.998 grams per mole. So I got to plug that in here now. 31.998. Okay? So now my box is completely filled out. Last step is to actually do the math. We're going to multiply the top together and we're going to get a number. We're going to multiply the bottom together. We're going to get a number and we're going to save dividing for last. So I'm going to pull out my trusty calculator again. 5 times 1 times 31.98. That gave me 159.99. I'm going to multiply the bottom together now. We got 22.4 times 1. That's 22.4. And then we're going to divide last, so that gives me 159.99 divided by 22.4, 7.1 grams of O2. So if I have 5 liters of O2, that is equal to 7.1 grams of O2. Guys, this is two-step conversions. Remember, all you care about is your starting point and your ending point. You're going to look at the Y diagram, which I'm giving you. You're going to map out how many steps it takes and then start plugging everything in. You always start with what they gave you. Whatever's up here goes down there, and where you want to go goes up top. If you're not in moles, you go to moles first, and then whatever's up here goes down there, and then you can go to wherever it is they told you to go to. If you follow these steps, guys, you'll never get lost. You'll never put these numbers in the wrong place, okay? I hope this helps. This is two steps conversions between grams and liters.